In the National Electrical Code, the term tap refers to a very specific type of conductor installation and does not simply mean a point of connection. The NEC defines a tap conductor as a conductor that has a smaller size than the conductor from which it is derived, and that connects to the main conductor at any point along its length to carry current to a device or equipment. The tap conductor must have an overcurrent protection rating that is not greater than the rating of the device or equipment it supplies. This means that a tap is a smaller wire that branches off from a larger wire and has its own overcurrent protection. The key aspects of a tap conductor, as defined by the NEC, revolve around conductor size relative to the main conductor and the presence of overcurrent protection. Firstly, the tap conductor must be smaller than the main conductor it is connected to. This difference in size is critical because it dictates the amount of current the tap conductor can safely carry compared to the main conductor. Secondly, and perhaps most importantly, the tap conductor must have its own overcurrent protection. This protection is typically provided by a fuse or circuit breaker that is rated to protect the tap conductor from overloads and short circuits. Without this overcurrent protection, the smaller tap conductor would be vulnerable to damage or failure if subjected to excessive current. The colloquial use of the word tap to simply mean any point of connection is not supported by the NEC and can lead to confusion and potentially unsafe practices. A point of connection, such as a wire nut connection, is simply a place where two or more conductors are joined together. It does not inherently provide any overcurrent protection. In contrast, a tap as defined by the NEC involves a deliberate design to safely reduce the conductor size while ensuring adequate overcurrent protection for the branch circuit. To illustrate the difference, consider a scenario where a large feeder conductor supplies power to a panel board. From the panel board, smaller branch circuit conductors are run to various loads, such as lighting fixtures or receptacles. These branch circuit conductors are protected by circuit breakers in the panel board, sized appropriately for the conductor ampacity and the load requirements. If a smaller conductor were to be connected directly to the feeder conductor without any overcurrent protection, this would not be considered a tap under the NEC definition. Instead, it would be a violation of the code because the smaller conductor would be unprotected against overcurrents. The NEC provides specific rules and requirements for tap conductors, which are outlined in Article 240.21. These rules dictate the allowable length of the tap conductor, the ampacity of the tap conductor relative to the main conductor, and the location of the overcurrent protection device. One of the common types of taps is the 10-foot tap rule. This rule allows a tap conductor to be up to 10 feet long without requiring overcurrent protection at the point where the tap conductor originates. However, there are several conditions that must be met to comply with this rule. Firstly, the ampacity of the tap conductor must be not less than 1/10 of the rating of the overcurrent device protecting the feeder or branch circuit. Secondly, the tap conductor must terminate in a single circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductor. Thirdly, the tap conductor must be enclosed in a raceway or otherwise protected from physical damage. Another type of tap is the 25-foot tap rule. This rule allows the tap conductor to be up to 25 feet long under certain conditions. Firstly, the ampacity of the tap conductor must be not less than 1/3 of the rating of the overcurrent device protecting the feeder or branch circuit conductors. Secondly, the tap conductor must terminate in a circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductor. Thirdly, the tap conductor must be protected from physical damage and be installed in a raceway. These tap rules are designed to provide flexibility in electrical installations while maintaining a high level of safety. By carefully following the requirements of the NEC, electricians can safely install tap conductors without compromising the integrity of the electrical system. It is important to note that the NEC is a complex document and that the rules for tap conductors can be difficult to understand. If you are unsure whether a particular conductor is a tap or how to properly install a tap conductor, you should consult the NEC or a qualified electrician. Improperly installed tap conductors can create a fire hazard and put people and property at risk. When designing and installing electrical systems, it is crucial to use the correct terminology to avoid confusion and ensure that everyone involved understands the requirements. Using the word tap loosely to mean any point of connection can lead to misunderstandings and potentially dangerous situations. For example, if an electrician is asked to install a tap without further clarification, they may assume that the installation must comply with the NEC tap rules. However, if the intention is simply to make a connection without any overcurrent protection, the resulting installation may not be compliant with the code. Similarly, if an inspector sees a conductor that is described as a tap but does not meet the requirements of the NEC, they may issue a violation. By using precise language and adhering to the definitions in the NEC, it is possible to avoid these types of misunderstandings and ensure that electrical installations are safe and code compliant. In addition to the specific tap rules in Article 240.21, the NEC also contains other provisions that relate to tap conductors. For example, Section 310.15 addresses the ampacity of conductors, and it provides rules for directing conductors that are installed in close proximity to each other or in high-temperature environments. These directing factors can affect the allowable ampacity of a tap conductor and must be taken into account when designing the installation. Similarly, Article 430 covers the requirements for motor circuits, and it includes specific rules for tap conductors that supply motors. These rules are designed to protect the motor from overloads and short circuits and to ensure that the motor operates safely. It is also important to consider the voltage drop in tap conductors. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC recommends that voltage drop in branch circuits should not exceed 3% and that voltage drop in feeders should not exceed 5%. When designing tap conductors, it is important to calculate the voltage drop to ensure that it is within acceptable limits. There are several factors that can affect the voltage drop in a tap conductor, including the length of the conductor, the ampacity of the conductor, and the load current. To minimize voltage drop, it is important to use conductors that are large enough to carry the load current without excessive resistance. You should also keep the length of the tap conductors as short as possible. In summary, the NEC definition of a tap conductor is very specific and should not be confused with the colloquial use of the word tap to mean any point of connection. Tap conductors are smaller conductors that branch off from larger conductors and have their own overcurrent protection. The NEC provides detailed rules for tap conductors, including requirements for conductor size, overcurrent protection, and installation methods. By following these rules, electricians can safely install tap conductors and ensure that electrical systems are safe and code compliant. When working with electrical systems, it is important to use the correct terminology and to understand the requirements of the NEC. If you are unsure whether a particular conductor is a tap, or how to properly install a tap conductor, you should consult the NEC or a qualified electrician. The National Electrical Code is not just a set of rules, but a comprehensive guide to ensuring electrical safety. Its guidelines are based on decades of research, testing, and practical experience. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address any emerging safety concerns. Therefore, it's crucial for anyone involved in electrical work to stay up to date with the latest edition of the NEC and to understand its provisions thoroughly. The NEC also provides guidance on the selection and installation of electrical equipment such as circuit breakers, fuses, conductors, and wiring devices. It specifies the minimum performance requirements for this equipment and outlines the proper methods for installing it to ensure safe and reliable operation. For example, the NEC specifies the types of enclosures that are required for electrical equipment in different environments, such as wet locations or hazardous locations. It also provides rules for grounding and bonding electrical systems to prevent electric shock hazards. Grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the source, which trips the overcurrent protection device and energizes the circuit. Without proper grounding and bonding, a fault can create a dangerous voltage on metal parts of electrical equipment, which can result in electric shock if someone comes into contact with it. Another important aspect of the NEC is its focus on preventing fires caused by electrical hazards. Electrical fires can be caused by a variety of factors, such as overloaded circuits, loose connections, and damaged insulation. The NEC addresses these hazards by requiring the use of overcurrent protection devices, such as circuit breakers and fuses, which are designed to interrupt the flow of current in the event of an overload or short circuit. It also requires that electrical equipment be installed in a neat and workmanlike manner and that all connections be tight and secure. In addition to preventing fires, the NEC also aims to protect electrical equipment from damage caused by overvoltages and undervoltages. Overvoltages can be caused by lightning strikes, utility switching, or other transient events. Undervoltages can be caused by power outages or brownouts. The NEC requires that electrical systems be designed to withstand these voltage fluctuations and that appropriate surge protection devices be installed to protect sensitive electronic equipment. The NEC also addresses the specific requirements for different types of electrical installations, such as residential, commercial, and industrial installations. It recognizes that each type of installation has its own unique challenges and hazards and that different rules are needed to ensure safety. For example, the NEC has specific requirements for the installation of smoke detectors in residential occupancies, which are designed to provide early warning of a fire. It also has specific requirements for the installation of emergency lighting in commercial buildings, which is designed to provide illumination in the event of a power outage. In addition to its technical requirements, the NEC also includes administrative provisions that govern the enforcement of the code. It specifies the roles and responsibilities of electrical inspectors, contractors, and other stakeholders. It also outlines the procedures for obtaining permits, conducting inspections, and resolving disputes. The NEC is typically adopted by state and local governments, which then have the authority to enforce the code. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC and for issuing permits and certificates of occupancy. Contractors are responsible for ensuring that their work meets the requirements of the NEC and for obtaining the necessary permits and inspections. In conclusion, the NEC is a comprehensive and essential resource for anyone involved in electrical work. It provides detailed guidance on the design, installation, and maintenance of electrical systems with the goal of protecting people and property from electrical hazards. By understanding and following the provisions of the NEC, electricians can ensure that their work is safe, reliable, and code compliant. Remember, when in doubt, always consult the NEC or a qualified electrician. Electrical safety is paramount, and it's always better to be safe than sorry. Consider the following scenarios to further clarify the application of tap rules. Scenario 1 involves a 100 amp feeder supplying a sub-panel. A 10-foot tap is made from the feeder to supply a 20 amp lighting circuit. The tap conductor must have an ampacity of at least 10 amps, which is 1/10 of the 100 amp overcurrent protection device. The tap conductor must terminate in a 20 amp circuit breaker or fuses that protect the lighting circuit. The tap conductor must also be protected from physical damage, typically by being enclosed in conduit. Scenario 2 involves a 200 amp feeder supplying a main distribution panel. A 25-foot tap is made from the feeder to supply a 60 amp air conditioning unit. The tap conductor must have an ampacity of at least 66.7 amps, which is 1/3 of the 200 amp overcurrent protection device. The tap conductor must terminate in a 60 amp circuit breaker or fuses that protect the air conditioning unit. The tap conductor must also be protected from physical damage, typically by being enclosed in conduit. The tap rules are designed to provide flexibility in electrical installations, but it is important to understand the requirements and to apply them correctly. If there is any doubt about whether a particular installation meets the requirements of the NEC, it is always best to consult with a qualified electrician or electrical inspector. Ignoring the specifics can create dangerous situations and code violations. The safe and proper method for creating a branch circuit from a larger conductor involves using a listed junction box, proper overcurrent protection at the source, and conductors sized appropriately for the intended load. Remember, using the term tap casually can be misleading. Always be clear about whether you are referring to a code-compliant tap installation or simply a point where conductors are joined. Consulting the NEC directly is always the best practice to avoid confusion.